In the last set of video on multiplication of surds in brackets, we saw how 3 root 5 plus 2 multiplies root 5 plus 3, and it gave us this 21 plus 11 root 5. And likewise, we saw how this multiplied this to give us minus 22 plus 7 root 6, and the square of 2 root 2 plus root 5 gave us 13 plus 4 root 10. Now we saw an anomaly where we multiplied two surds in brackets, and then it gave us a rational number or a whole number. Why didn't it give us normal surds as usual? Why is this one different to give us whole numbers? Right, so this idea is behind conjugates of surds. So let's take, for instance, we have root a plus root b. It is being multiplied by root a minus root b. Now we are saying that root a plus root b is the conjugate of root a minus root b. Okay, let me come again. Root a plus root b is the conjugate for root a minus root b. The only difference is the plus and the subtraction sign here, the addition sign, the subtraction sign. So if we go ahead and perform the multiplication here, so we have root a multiplied by root a minus root b plus root b multiplied by root a minus root b. Therefore this will give us root a squared minus root ab plus root ab minus root b squared. So therefore this will be let's just say it is root a squared minus root ab plus root ab will nullify each other, and this will give us root b squared. So instead of going through all this whole process of opening the brackets, we can just go directly from here to give us this. So before we proceed on the next thing, let's try this now. So we have 4 root 3 plus root 2 is being multiplied by 4 root 3 minus root 2. There should be a square root here. And now instead of opening the bracket like we did in the previous video, we can just say that, oh, this will give us 4 root 3 squared minus root 2 squared. And 4 root 3 squared will be 4 squared root 3 squared, applying the laws of indices, and this will give us root 2 squared, just as it is. So this will give us 16 multiplied by 3 minus 2. So this is 48 minus 2, which is equals to 46. Now we can see how short it is. So what is conjugate of a surd? And if we have a surd, how do we know this conjugate? So let's begin. So let's say I have a table surds, and we are looking for the respective conjugate. Now if I have root 3 minus root 2, the conjugate will be that I rewrite this thing as root 3 and root 2. However, instead of writing minus, I'll write plus. It's as easy as that. So let's say again I have root 2 root 5 plus 3 root 3. Now the conjugate will be 2 root 5, okay, minus, this time because plus is here, then definitely minus will begin. So this will be minus 3 root 3. And if we proceed further, we have 1 plus 2 root 2, or let's say 1 plus root 2. The conjugate therefore will be 1 minus root 2. The whole game is to change the sign in between. Let's take 2 more examples. I have 2 root 3 minus 4. The conjugate will be 2 root 3. Okay. Instead of writing a negative, it will be a positive plus 4, not root 4. Also, if we are given 5 plus 3 root 2, The conjugate will be 5 minus 3 root 2. Now that we can determine conjugate of a surd, how then do we know, okay, if I multiply these two together, we know that definitely it's going to give us the result when it is being multiplied together, will give us a whole number. So let's begin. Let's say that starts from 5 going upwards. 5 plus 3 root 2. Apply the multiplication sign between them. That's 5 minus 3 root 2. Just like we have learned before, that when we have two surds or a conjugate of a surd being multiplied together, let's say root A plus root B is multiplied by the conjugate root A minus root B, the result will be root A squared minus root B squared. So this brings us to the idea of difference of two squares. Also, this could be in another format. Let's say root A plus B. The conjugate of root A plus B is definitely root A. So instead of the plus sign, we have the negative sign minus B. Therefore, the result of the multiplication will simply be root A squared minus B squared. So we square this, and we applied the subtraction sign. We take the square of this, and we apply the subtraction sign. So it goes on and on like that. So let's solve this now. So to solve this, that means we'll just take the square of 5 squared minus the square of this 3 root 2 squared. Simple. So this will give us 25 minus 3 squared multiplied by 2. So this will be 25 minus 9 times 2, 25 minus 18, which is going to give us 7. Likewise, let's go a bit backwards. I have 2 root 3 minus 4. 2 root 3 minus 4. Now we know the conjugate of this is 2 root 3 plus 4. Now to multiply these two together, we take the square of this. That's 2 root 3. We subtract it. We subtract the square of 4 from it. That's minus 4 squared. So the square of these, applying the law of indices, will be 2 squared multiplied by 3 minus 16. So this will be 4 times 3 minus 16, which is 12 minus 16, which is equal to minus 4. Now let's take 2 more examples on this. Following the, let us pick something else entirely. So we have 7 root 2 plus root 3. What is the conjugate of 7 root 3 plus root 3? So the conjugate will be 7 root 2 minus root 3. And to solve the multiplication of conjugate surds, we take the square of 7 root 2 and we subtract the square of root 3 from it. Now this will give us 7 squared multiplied by 2, applying the law of indices, and this will give us minus 3. So this will give us 98 minus 3, which is equals to 95. One last example, and that will be when we have 2 minus root 3. Now the conjugate of 2 minus root 3 is 2 plus root 3. So if we find ourselves in this scenario where we have the surd and its conjugate together, we take the square of 2 squared, and we subtract the square of root 3. So this will give us 4 minus 3, which is equals to 1. Now that we have learned on conjugate of surds, in our next video we'll learn how to apply the conjugate of surds in division of surds in brackets, which is most likely called rationalizing of the denominator. What we did back then in the division of surds is just for single surds. However, when it comes to surds in bracket and want to divide a surd by a surd in bracket or a number by a surd in bracket, we go ahead and apply the rule of rationalization.